So when we add and subtract radicals, doesn't matter which of the two operations it is, the rule is that we have to get these two numbers to be the same. So the radicals have to be identical. So right now they're not. So what we do is we start by making a factor tree for each of those numbers to see if we can pull out any perfect squares. So if we start dividing into 48, we have a lot of options. I could go with 8 and 6. And I'm going to keep breaking this down until I have only prime numbers. And when I do get prime numbers, I circle them. So these all get circled. So 8 is done. I can keep going with 6. Those are both prime, so those get circled. So now I go and write out a big radical. And I list out all my prime factors in order. So I have 4 2's and a 3. And this 3 comes back down because that's part of my answer as well. So now inside the radical, anyone that's a pair gets circled. And each time I circle something, I'm bringing one of those to the outside. And anything that's out there together is going to get multiplied together. So this radical, the final answer would be 2 times 2 times 3 gives me 12. And I only have a 3 left over in the radical. So when 3 radical 48 is simplified, I get 12 radical 3. So now I go over here and do my other radical. So 4 breaks into 2 2's, and 3 is already prime. So those are the only primes that make up 12. So just like before, I'm going to write out my radical and list my primes in order. And like before, this number comes down and sits out front. Now, again, I'm circling pairs, so the only thing I can pull out this time is a 2. So when I multiply those numbers together, I end up with 8 radical 3. Now, just like what I wanted, my two radicals match. So now I'm allowed to add them. So I'm really doing 12 radical 3 plus 8 radical 3. And the rule now that we have like radicals is we just add the coefficients. So this becomes 20 radical 3, and that's my final answer. The same rule would apply if I had instead been subtracting these two radicals.